Hi, I'm Joanna S. Lucas from PHY124 and this is for my subject, Physics for Engineers.
Hi, I am Joanna S. Lucas from PHY124. In this video, I will discuss how we can solve a problem using a components of vector in addition, or how we can find a vector sum. So here, this is our figure where this is our vector A and this is our vector B. For us to know where is our vector sum will be, we will find the tail of our vector A, and this is the tail of vector A and the head of our vector B. So since this is the vector B, this is its head, we will connect two of them for us to know where is our vector C is, or our vector sum. So since we already found it, we will put the value of vector A and vector B. So vector A has 5 meters and 60 degrees, and for vector B we have 4 meters and 20 degrees. For us to know the vector sum and its angle, we have to use two equations here, where vector sum or vector C is equal to square root of cy squared plus cx squared. And for its angle, it is theta equal inverse tangent of cy over cx. Since we don't have cy and cx, we have to find it first. So to find it, we also have equation for that, where cy is equal to ay plus by and cx is equal to ax plus bx. Since we don't have ay and by and ax and bx, we will find it also by using its formula,
Where ay is equal to a times sine theta. It is sine because it is at the vertical line or in the y-axis. So ay, distributing it, ay is equal to 5 meters times sine. The angle of RA is 60 degrees, so 5 meters times sine 60. So our answer, or RAY, is 4.33 meters. And for our BY, since it is also in y-axis, we will use sine. So B times sine theta. So BY is equal to B. The RB is for 4 meters. Our angle is 20 degrees. 4 meters times sine 20 degrees is equal to 1.37 meters. And now that we're done finding our y's, we will find the x. Ax is equal to a times cosine theta. Since it is at the horizontal line or at the x-axis, we will use cosine. So ax, RA is 5 meters times cosine and its angle, which is 60 degrees. So 5 meters times cosine 60 is equal to 2.5 meters. And in our Vx, we have V cosine theta. So Vx is equal to our V, which is 4 meters, cosine this angle, which is 20 degrees. So Vx is equal to 4 meters times cosine 20 degrees, which is equal to 3.76 meters. So our AY is 4.33 meters, AX is 2.5 meters, and our VY is 1.37 meters, and our VX is 3.76 meters. After knowing that, we can now use the equation for CY and CX, where CY is equal to AY plus BY. So let's substitute it since we already know it's our AY and BY. CY plus our AY, which is 4.33 meters, plus our BY, which is 1.37 meters. So 4.33 meters plus 1.37 meters is equal to 5.70 meters. So our CY is 5.70 meters. And for our CX, our equation there is AX plus BX. So let's substitute it. Our AX is 2.5 meters plus our BX, which is 3.76 meters. So 2.5 meters plus 3.76 meters is equal to 6.26 meters. So since we already know our CY and CX, we will use it to find our vector C or our vector sum and its angle. So let's erase it. For us to know the vector sum or our vector C, our equation there is vector sum or vector C is equal to square root of CY squared plus CX squared. Let's substitute it. Our CY is 5.70 meters squared plus CX, our CX is 6.26 meter squared. So vector C is equal to square root of 5.70 meters squared plus 6.26 meters squared. So let's calculate it. Our vector C or our vector sum is 8.47 meters. After knowing that, we now solve the angle. So our equation for angle is theta is equal to inverse tan of CY over CX. So let's substitute it. Theta equals inverse tan of CY. Our CY is 5.70 meters and our CX is 6.26 meters. Inverse tan of 5.70 meters over 6.26 meters is equal to 42.3 degrees. So our vector sum or our vector C is 8.47 meters. Angle is 42.3 degrees. This method is more accurate than graphical method. That's why I use this to show you how we can solve or find the vector sum and its angle. This is the method that uses components of vector. That's all. Thank you for watching.